Sorry, as I said previously, I really don't like Chrome, but I have to use it for that, and it goes against every natural thing in my body, and I can't even resize that dang Chrome window correctly because Chrome, for some reason or another, doesn't support the vertical monitors. For some reason, I don't know. It doesn't make any sense. So I'm so sorry. We're cutting here. I have a funny video about gravity that I'd like to react to, or that I'd like to talk about. And I'd like to talk about it particularly because I'm not 100% sure if it's genuine or not. Okay. I'm just give me back set up again. There we are. And I also this time I have Arnold on hand. So sorry for that again. I'm really am a potato sometimes. I also for the first time for the first time in ever actually, I've managed to bring my drawing pad, my own drawing pad from my parents' house because it was still there for when I used it during COVID. and I can now write down things properly without needing the drawing pad from either my flatmate or someone else. So this is very nice, and it supports all of the things. I can do anything I want on that, and it's a very nice thing. I like that there is actually Linux support out of the box for Wacom tablets, so you don't need to do anything. We will be using this to write stuff down in case I need to explain things in a written way. Okay. Now that I've done that, hello, back again. Now that I did that, I will close this tab maybe. Yes, I will close this tab and we will go on finally. And again, I'm so sorry about that. I keep forgetting about that. I can share the audio now. That is very nice. Yes, now you should be able to hear something.
Time gate moments.
I'm just having a look if this is actually true on my phone. I'm so sorry. Hang on one second. Okay.
Welcome. Ding ding ding.
Okay. Welcome. Yeah. All righty, tight. You can hear it. Very nice. So let us begin now. As people in the comments point out, seriously, is this a joke? And dude says it's far from a joke, but I'm not actually sure. If he's serious, I can't judge. He's so on the edge of things. So let's actually dive into it.
Time gate moments. Welcome. Ding ding ding.
Hello. I like the intro. I like the music. I also really like the fact that he does his own intro music, which at least I assume that's him. And in case it is, I really like it. For some reason, I like it. I should do something like that as well. It's a little bit silly, but it's good enough. Frankly, that's great. I like it. I like it a lot. Okay. And so on. Let me just, I've only watched, I looked it up earlier, I only watched 9 minutes of that, of this video, before I decided that I would like to talk about it.
Hi there guys, you are watching The Earth is Flat, 100% for sure, episode 19.
Hardly 1%.
Welcome.
Hello.
Irashamase. Ni hao. Sodawo. Habari yako. Ahlan wa sahlan. Assalamu alaikum.
I like that he calls this language Islam.
Bienvenida.
Just a little,
Namaste. Malo so ifua.
Yes.
Now,
hello.
Many of the people that may be watching this video, whether a professor or student or enthusiast or some other person who's even knowledgeable about cosmology and astronomy, when we say
I would consider myself to be such a person. I think we can agree that I'm knowledgeable about astronomy, and I don't know specifically about the cosmos because that has many different meanings, but definitely about astronomy. Although I'm not a professor, I'm just repeating it for either new people if the actual people I react to watch the stream. I have a master's degree in astronomy and about to finish my master's degree in physics, and I hope to move on to a PhD in astronomy.
Say gravity does not exist. You are probably thinking,
Somehow,
what
yes.
on earth is this guy talking about? Does he not know about X, Y, Z, and A, B, C, D, E, F?
Yes. Now, the typical setup for flat Earth things is that the flat earther says that, oh no, I know this and that, and I'm not going to make easy mistakes before going on to making easy mistakes. That is the
And
typical
on
setup.
the other hand, once you fully understand and comprehend the fact and reality that our Earth is flat and
You
motionless,
see,
it
I'm not
will
sure.
even become crystal clear to you, regardless of how staunch
I
you may have
don't
been in
think.
opposition, or
But
that you're just a skeptic,
we
or you just
may
don't
find
care
out. Maybe
because you
I'm
have not done
proven
sufficient
better
research into this topic.
I doubt it, but maybe I
Nevertheless,
will.
before we can jump into any conclusions, we must first consider these three basic, observable, experimentable, and realities.
I mean, we're already in 3 for 3 with bad here. Okay. Let's so the first one is, don't confuse the falling of objects with so-called gravity. Well, I mean, there is some truth in the statement in that gravity isn't only stuff falling down. It's also a whole bunch of other things that are, even though not particularly important in our day-to-day lives, but certainly when it comes to having a holistic view of gravity, that become important, like orbits or to a certain degree and beyond a certain point, even general relativity and things like that, right? So the falling itself is merely a force acting upon the mass and causing an acceleration, right? But so this is not, of course, the whole field of gravity, but it is very much due to gravity, and I believe that the fine gentleman here disputes that this to be like that. Okay, that's the first point. Second point is, you must understand there's only up and down. I disagree. What about right? To you it's left, the camera is flipped. So what about right? What about left? What about a little bit up and a bit left as well? So I have some problems with that. And there's a natural law of density and buoyancy. There is a law of buoyancy in nature, that's correct. Density, however, is a scalar quantity. It cannot exceed a force. It cannot exert the force by itself. Yeah, so my flatmate has just texted me that apparently my audio is a bit problematic. I'm sorry about that. I was unaware, but everything seems to be set up correctly. Let me have a little bit of a look myself. Sorry for this break. Can I speak clearly? Okay, let's test. Sorry. I need to have a look on my phone. Sorry. I'm sorry to inform you. It's fine on my end, or at least on my phone. It was fine enough. Maybe I should move the mic a little bit further away. Okay, let's continue then. The third thing is, there's a natural law of density and buoyancy, and I said there's a natural law of buoyancy. Certainly, there is not a law of density, because density is just a quantification for how much material there is based on mass in a given volume. It doesn't. There is no law, but we'll see what they mean. Maybe we can find out that we are misjudging
of life and nature. The first of these is that do not confuse fallen objects with the so-called gravity, just like you would not confuse things going up from the earth to the sky with the so-called gravity. Think about that carefully. The second thing is, you must understand that there is only up and down. It is either a horizontal terrestrial platform or you are going up vertically into the sky. There is no spinning globe Earth in space. Forget it. That is 100% not true.
Okay, so his first thing for learning why gravity is false is that you need to accept from what I understand from this description that there is in fact a flat Earth. Well, I mean that's a little bit you're kind of presupposing one of the conclusions right here, right? But okay.
The third basic and cosmographic reality you need to understand
Cosmographic.
is
That's a
that
good word.
there is a natural law of density and buoyancy in nature and physics. We can assure you
Yeah,
100%
that's at least half true, right? There is a law of buoyancy.
that once you understand these three basic facts, you will come to the conclusion that the so-called gravity is a fake, fictitious, or fabricated force in order to promote and reinforce the globe Earth and heliocentric, mediocre, and make-believe. So,
I disagree. We'll see.
the question is this: what on earth is gravity anyway? Here
Yes,
is a
what is gravity?
basic dictionary definition.
I'm content with the first explanation for everyday purposes. The force that attracts the body towards the center of the Earth. That's for your basic everyday meaning, and or towards any other physical body having mass. I'm fine with that. That is sufficient for an introduction.
Now, as you can see, we are being told that gravity is the force that attracts a body towards the center of the Earth or towards any other
Yes,
physical body
that is
having
correct.
mass.
I agree.
In other words, we are being told two things. Number one, things fall down on Earth because of gravity, whether it's a rock or a rocket
in
or
principle,
an airplane, God forbid,
I mean,
or any other
it
heavy
just said
objects
the tract.
coming
It doesn't
down
say
on
anything about
Earth.
falling.
This all happens because of the so-called gravity. And the other thing we are being told here by this definition is that a larger body of mass is able to attract
Why the question marks?
smaller body of mass because of gravity. Now,
Yes,
just for
it
a
does.
moment, think outside the box and
okay.
ask yourself the question: if this is really true about gravity, how
Yes.
comes this massive terrestrial plane
Oh, no.
we know as Earth is not falling or collapsing on the sun or any other?
Here we go. Okay, so this is now where we start to get interesting. Okay, so let me explain. Yes, you should see me now. And the night planning to do so, it is precisely cut like the cut. Wait, I need to go there. No, I was right here. There we are. So the cut here. Oh, sorry, I need to the cut here in the where my face commands and where the writing thing starts is precisely aligned without me planning for it. Of course, I did plan for it. Of course, certainly I did. Don't believe anything past me has said. Okay, so why? And this is a somewhat somehow common flat Earth question. If this here is the Earth, let's say, let's make it like that. It's very ugly. Let's say this is Earth, right? And here we have the sun, not to scale, right? Not to scale and scale. Yeah, sure, Olaf, sure. Why then does the Earth not just fall inwards? Maybe use another pen. Why then does it not just fall inwards? Well, that's a good question. Kind of. Because if we know mass attracts mass, I'm going to use Newton's formula here for the purposes of this demonstration. This falls very much into the realm of classical mechanics. I'm using small m and big M, by the way. The two m's being the masses, of course. So the force exerted from one planetary body on the other should mean that they would eventually collide. So why then don't they? Well, that's because this force here is only one of the necessary forces. This is the force, let's say Sun Earth, SE, not Southeast. That's Sun Earth, and of course it would apply the same way to the sun because equal and opposite and then all that stuff. And so essentially this is one of the forces, but you are missing one. You're missing the fact that we have, for whatever reason, in this case because of how the solar system formed, we have a velocity in this direction. In my drawing here, again, this is not to scale. This is just an exemplary statement. And now the velocity here, because there is an attraction inwards, will lead to a force outwards, such that the object will move along an orbit. This is exactly what orbits are for. When you have the sun here, right? You have the sun here, and then you have, this is very exaggerated. Earth's orbit is almost perfectly spherical. I'm just trying to draw it nicely. It's still ugly. I'm not particularly good at drawing. I'm sorry. So if this is the sun, right, and then this is the orbit. The orbit is there because we have an outwards force coming from the fact that we are having an initial velocity that keeps us going around in the orbit. So this is why Earth doesn't fall into the sun, and why the moon doesn't fall onto the Earth, and why no planets just collide like that, because there is more involved than just, it's not stationary, it's moving, and this movement creates force. You know this force from going around circles in some sort of vehicle, be it a car or a train or a motorcycle or things like that. That's what's causing this. Okay. All right. Oh, I closed myself. Where is my other window? There it is. All right. Let's keep on going, shall we? Yeah. Okay. So that's the first thing.
The so-called is not falling or collapsing on the sun or any other so-called planets. How comes? Likewise,
it comes because it doesn't it doesn't sit still. It moves. It has a velocity, and this velocity causes a centrifugal force that keeps it up, if you will.
How comes this massive CGI of Saturn?
Yes,
look at the size
I mean you had the choice not to just show CGI.
It's not falling or collapsing on the sun.
Same reason.
Because of the sun.
Same reason. Different numbers.
Gravitational pull. How comes? What about the glorious moon?
Same reason. Different
sometimes
numbers.
referred to as one of the local satellites. How comes? If the moon,
you need to fit that in there. That's unnecessary to doubt the distances that are given to us by any sort of organization.
Is really a land mass, a place, a platform, a solid platform that you can.
I would love to see any evidence for this statement. And I would also love how you come up with 2,700 miles, because I swear you could do calculations with that based on triangles that would completely ruin the idea of a moon that high.
Land on, as they say, back in 1969. If that's really the case, that the moon has dust, debris, craters, rocks, mountains, whatever, then how comes the moon is not falling or collapsing on the surface of the Earth? How comes?
That's correct.
Isn't gravity what makes things fall on the surface of the Earth because of their mass?
I see.
Take a look at this illustration.
I see.
And ask yourself the question.
I see where the confusion comes from. Because it is also important not just to laugh, even though I sometimes do that as well. Is my beard weird? Weird. That sounds fun. Sorry. Is my beard right? Yeah. Sorry. I just shave a little. So no, I didn't want to. I wanted to do that. Okay. So that's the thing, because the definition you gave says that first of all it is the force that attracts things to the surface of the Earth, because almost. I should maybe insert a little line here. Almost all of our daily experiences, for almost all of our daily experiences, the notion that gravity is the force that pulls things towards the Earth is sufficient, right? If I'm here, it acts that way. Here it acts that way. Here it acts that way. Here it acts this way. No, here it acts that way, and so on and so forth, right? Towards the center of the Earth, or the gravitational center of the Earth, I should say. And of course, if this is your thing, and then you wonder, well, if I have the moon, I'm now drawing the moon in yellow because, as everyone knows, it is made out of cheese. If the moon's here, this is not to scale. God, is it not to scale? Then you could ask the question, well, why doesn't that simply go down? Well, it does a little bit. Of course, there is gravitational force between those, but it also, again, it has a velocity, and this stuff's moving away due to centrifugal force, yada, yada, yada. Okay, cool. We got that. But the strictly correct definition that should have been put there for the Webster's thing. Sorry, I want to adapt the red to be a little more bright. Yeah, the strictly correct definition would have been that one. For almost all purposes that aren't strictly scientific in the realms of relativity, this one would be the one you'd go to. Yeah. So the force of gravity, or how I would define gravity, is the force that rises between two masses. The attractive force, of course. Right? Not every force, but the force due to the fundamental force in physics called gravity. That's a whole different kind of worms. So yeah, different. But so the confusion here comes because the definition you read is non-ideal for scientific purposes there, because it says at first that gravity is the force that pulls things towards Earth. Well, yeah, it says not wrong, but it's not the whole picture, and you need the whole picture if you're asking questions like that. All right, let's go back. Let's go back again. There we go.
Which is heavier, raindrops or the moon?
Certainly the moon. But the raindrops are in no place to have a velocity. They don't have a velocity high enough to orbit the Earth. And if they did, they would orbit the Earth if they had a sideways velocity. And you could even calculate how high this would be. Of course, not in the atmosphere due to friction, blah, 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 blah. I know. But in general, this would be possible.
Then how comes rain drops to the surface of the Earth? Because
Gravity.
of gravity. But the moon, which is much greater in mass compared to rain, stays in the sky.
And you see now, hopefully, maybe that I was wondering whether this is sincere or not. Okay, I'm will be doing my best at a kind of 2-scale drawing here. If we say that this is, if we say that this here is Earth. Maybe, yeah, okay. Earth. And we say the cheese moon, it's not cheese, by the way, is here. I'm also trying to get the sizes about right now. It's again very much not to scale. The distance would be a lot bigger. But the question is now, where does the rain? The rain's here. My friend, the rain is here. I can't even draw it close enough because it would already be higher than the space station. This is where the rain is. The rain, right? Let's make a little table here, right? Let's compare the rain versus the moon, right? Let's say here moon, rain, far away. I should write a little bit smaller. Far away. Yes. No. High velocity. Yes. No. In the atmosphere. Why am I writing atmosphere in capitalized? Atmo. No. Yes, I think we can conclude here that this one will fall and this one may not fall. I don't have provided enough information, right? But in general, this is orbit fall. That's the difference. You have it right there. That's the difference. Okay. Let's keep on going.
Does that make any logical sense?
Yes.
What's going on over there?
when you
The
know
fact of the matter
a little
is
bit
this:
more, then yes,
the
this
Earth,
does make sense.
despite it is massive mass compared to the moon, has absolutely no gravitational pull or effect or impact on the moon.
Well, they have another banger here. That's wrong. In case you were unaware, that is completely wrong. The Earth has quite some effect. As a matter of fact, if again, this here was the Earth, and the Moon would be here, and the Moon has a velocity component in this direction, and it has the attractive force in this direction as it does in reality of Moon Earth, right? If this force, for whatever reason, magically disappeared, the Moon would just go blasting off with its velocity that it has at this point in the orbit where it is at. I don't think that this should be a contentious statement. Okay, let's get back.
Whatsoever, just like the sun has no gravitational pull whatsoever on the Earth.
Same story here. If the gravitational pull of the sun would suddenly stop, Earth would just go blasting away with its orbital velocity towards the direction it is currently moving.
Or the moon or any other star system. So guys, before we dive into the main video, visuals, topics, and argumentations, let us first identify where on earth is this madness of gravitation? Where is it coming from? So yes, here we go. Most of it in terms of
the English. Okay.
Modern understanding, CGI, and programming, it goes back to this guy here, Isaac Newton, and his fellows back then. Hence is known as the Newtonian system of astronomy. So yes, so credit is given to him. Remember those pictures and images in books and what have you, and posters, where there was a guy sitting under a tree, an apple falls on his head, and then eureka, he discovered the law of gravitation, etc.
That's not a true story, I think.
Anyway, since the good days of Isaac Newton, this stuff here, as well as a heap of all kinds of other things, have been relentlessly pumped into the media system, the publication, academic and schooling system, the television, films, and cartoons system, and those many kinds of posters. You probably had a globe in your classroom, right?
No, actually we didn't. And I know no class that had one in their classroom. Maybe it's different in Austria than it is in other parts of the world. We didn't have one. That there was somewhere in some small geography archive thing, but I don't think we've ever looked at one in great detail. I mean, we had an atlas. That's enough for our purposes.
Could they let you have miss out on that? However, the fact of the matter is this, and the majority of people seem to have completely missed the whole point, is that most of this, in fact, 99.9%, is based on assumption, supposition,
kind of
and theory.
Sure.
As you can
see
from
tell
this
us.
Extract sampled by Professor Airy in his lectures on astronomy, where he refers to Newton and the way he worked.
Yes.
As you can clearly see here, the basis or the premise of Newton's so-called discovery, as well as those who promote his theory, is that it's based on assumption and theory, not facts. In other words, this is like saying it could be like that, but we are really not sure. Take a look at this one here.
No, that's not
just to show you.
I think this is more of like the way that the old-time astronomers talked.
You are real people, real professors, contemporaries, what they thought.
The theory that motions I'll be reading it. The theory that motions are produced through material attraction is absurd. Attributing such a power to mere matter, which is passive by nature, is a supreme illusion. It is a lovely and easy theory to satisfy any man's mind, but when the practical test comes, it falls all to pieces and becomes one of the most ridiculous theory to common sense and judgment, which is by Sir Richard Phillips. I don't know the man. This is to Professor Bernstein. I don't know if this is regarding gravity, that motions are produced through material attraction. I'm not sure if it is talking about gravity. Maybe this is a discussion about what is the actual cause of gravity. Is it a particle? Is it some interaction between particles we already know and things like that? I think that's more of that kind, but maybe I'm wrong here. The following extracts are taken from A Million of Facts by Sir Richard Phillips. I don't know the man. If the sun has any power, it must be derived from motion. Why? And if acting on bodies at a distance like Jupiter or on his moons or the Earth on its moon, there must be an intervening medium to conduct. It's momentum through the system. Okay, no. Now that comes down to ether again, where they thought that everything kind of needs to have a medium. We now know, or it depends strictly on what you think of as a medium. If you say space-time is a medium, then I suppose. But this is more of a philosophical argument coming from that. There needs to be some stuff because other than that, gravity wouldn't work. But this is not what the simple description of gravity is about at all.
This one is by Professor Bernstein.
Yes.
In his letters to the British Association, where he identified the whole thing as a supreme illusion, as well as the most ridiculous theory to common sense and judgment. This is no joke. Likewise,
again, I'm not sure what he refers
taken
to.
from A Million of Facts by Professor Richard Phillips, where he says, if the sun has any power, it must be derived from...
I'm just going to Google that man. I don't know who he is, right? Sir Richard Phillips was a publisher, an English school teacher, author, publisher, and vegetarianism activist. He died in 1840, was born in 1767. Hardly an authority on gravity, I would say. Okay, so he has written that he disagrees with the theory of gravity. One clap for effort of writing a letter.
Ocean, and if acting on bodies at a distance, like Jupiter on his moons or the Earth on its moon, there must be an intervening medium.
No, there must not. This is a simple statement of fact that is presented with certainty and can be dismissed because it doesn't provide any evidence. We do not possess a single evident proof in favor of the rotation of the Earth around its axis. Well, I disagree, Dr. Schöpfer, or Schäfer, maybe. It isn't an Ö, because I know that letter. But let's Google him also, or her. Dr. Schöpfer. To know who that man is. And well, neither does the internet. Maybe I should really write the OE. Hang on. Oh, maybe French. That's a good guess, actually. That could be French. By the way, not a lot of people are watching. If you would write something in the chat, if you want, that would be highly appreciated to keep me entertained and to know that there are actually people watching. I cannot find anything on a Dr. Schöpfer. All right, moving on.
We are talking about the findings.
I mean, it's not really. It may be anglicized. Yeah, this is correct. Yes.
Observation and opinion.
That is a good idea. I mean, there is, of course, a Dr. Schöpfer, but Schöpfer isn't exactly the most ridiculous name. There is a Dr. Schöpfer in the Austrian Red Cross office. There is several doctors with that name, medical doctors, that is. There is a thing about applied numerical modeling in geomechanics from 2020. I don't think this is the Dr. Schöpfer.
Of doctors, professors, teachers, real men and women contemporaries, and others of that nature. Remember, these free thinkers and professors, they were never exposed to or subjected to today's CGI, optic illusion, and special effects from television, internet,
I mean,
and space agencies. So yeah,
no, I mean, first of all, you can make predictions from the general theory of relativity, the general theory of relativity, that are shown to be very reliable. You can make calculations with planetary bodies, even with simple Newtonian physics that have shown to be true. For example, the discovery of Neptune by Wilhelm Herschel, right? By Herschel, I think it was, or was it Uranus? No. It was Neptune. Yeah, that's correct. It was discovered in 1846, numerically, nicely enough. And Herschel discovered Uranus, by the way. Uranus, I should say, probably. And it was because let me show you. So, nice. So the model at time, we're talking the late 1700s, early 1800s, was we have the Sun, right? We have Mercury, not Freddy, unfortunately, which is a joke that you only find funny if you know what t-shirt I'm wearing. Okay. We had Venus, Earth in no scale, of course, not to scale. Oh my God, is this not to scale? Then we had Mars. I should probably move Mars a little bit closer. We had Mars. We had a whole bunch of asteroids that weren't known, almost any at the time. These are the planets that in German we call them stone planets, which I really like. I find that funny. Now come the gas giants. We have Jupiter. I'm drawing them a little bit bigger. We had Jupiter. We had Saturn. And then, that was the last planet at the time, we had Uranus. And now, Uranus was discovered in 1780 by Wilhelm Herschel, with, at the time, the biggest telescope, I believe it was, in the world. And now something interesting occurred. According to the calculations, now, just in case, just for Uranus, for Uranus, the orbit at a specific time at a specific place should have looked something like that, right? That's the predicted orbit. Predicted orbit. From what we know from classical mechanics, Newton's equations, although it was a little bit more complicated at the time. You had things like Euler-Lagrange equations. You had Hamiltonian operators. Maybe no, I don't think. No, wait, hang on. Hamilton wasn't a thing yet. You had some Lagrange functions, a little bit more complicated, but it boils down to essentially being Newton's laws, but in a different kind of formalism that allows you to make more predictions, or easier predictions, I should say. But when they looked at the actual orbit, observationally, what they found is that the orbit was here. Far outside what is predicted. There was a difference here. And so they thought about, first of all, they redid the calculations, of course, because you can always be wrong or have miscalculated or anything. Wait, hang on. Difference. So you could always, of course, get anything wrong. So they redid the calculations. They came to the same conclusion as before. Now they thought, well, what if hypothetically, we place a planetary body, and this is such a nice example of science. They made an hypothesis. What if there is an eighth planet below or beyond Uranus? How heavy or how massive would it have to be in order to show this difference in the orbit here? So they thought about the hypothetical eighth planet, right? Eighth planet. How massive should it have to be? And so they did a calculation, and well, if there is an eighth planet, it would need to be from this, and it should move there. It would have a velocity of this and that, and so on and so on and so on. And then they boiled it down to a few possible final results. And they went to astronomers and said, you go now and you watch this place in the sky on Saturday at 2:14 or something a.m. And the astronomers went ahead and did that, and they set up and they looked at a very specific place in the sky. And sure enough, there it was. The calculations were confirmed. The predictions that you have to do. This was a direct test of our understanding of classical mechanics within our solar system, and it was successful. Success! It's actually there. So they called it Neptune. And it's now known as the eighth planet. And it was predicted before it was seen. Right? Predicted before it was observed. And that is remarkable. That is truly remarkable. And that is the power that science gives you. You are now able to predict the future and things you haven't seen yet, which is extremely cool. That's why I like science so much. You essentially turn into I don't want to say time traveler, but you get almost supernatural powers with it. Calculations that predict the future.
This is no joke. Flat earthers,
and this is only one of the many things that you can do with science, but it's certainly, I'd argue, the most effective show of our understanding of gravity.
That they are not just saying things for the sake of media and this and that. Therefore, on one hand, it is really a waste of time to break a butterfly on a wheel. But on the other hand, as astronomy and all science, modern science is beset with fancies about attraction and repulsion, it is necessary to try to eradicate them.
How? Why? Where's the evil in that? How is it not a valid scientific hypothesis to say something attracts and something repulses?
Look at this experimental explanation in relation to gravitation and attraction. If there are two bodies and it is required to move A to C, the force moving A to C must proceed from the side A. Either some impact or some involvement of a motion towards C must act at A to carry A to C. The modern schools of astronomy, however, assert
that's a very nice book.
B may move A to C and A move B to C.
I think you
and
can
this
read.
is mutual attraction. Hence, it is necessary to believe that B acts on the side A where B is not present, and that A acts on B on the side B where A is not present. In other words, A is required to be where it is not, and also be in force at A, so as to move B to C, all of which is absurd.
If that is truly absurd, then, my friend, you have a problem with another force, and it's called electromagnetism. This is also exactly what electromagnetism does. Now, we've figured out the details about electromagnetism a little bit quicker than we figured out the details about gravity. Not classically. Classically, gravity was figured out first. But when we look at, for example, okay, so if that is a problem, that you say, how can A attract B? It was B. And the point here, which is a little bit weird to call a point C, I would either call it small c or maybe call it 1 or something like that. But sure, let's call it C. How can A act on B and B act on A if B is here and A is here? Well, you could ask the same thing with two magnets. Let's not make this about gravity. Let's make it about magnets. We know today that there is what's called a magnetic field, right? And the magnetic field, or all magnetic fields, behave according to certain laws. And if you want to get into a ridiculous amount of detail, you could say that all of electromagnetism can be summarized with saying if you write down the correct meanings of all of this is the electric field. This is the B field. This is a differential operator, if you want. This is the divergence of B, we also call it. I won't explain now what a divergence is. To go way overboard. And I could now write all the others, the other two as well, but these are the only two I know of heart. I would need to look the others up. This is 0. These are the only two I know. Sometimes there's a minus here. I think I forgot that. These are the only two I know. I would need to look up the others. If your only argument is, well, B's here, how could it affect A that is over here? Well, I'm sorry. You also have a problem with electromagnetism. We just know that it exerts a field. Now, what if, and this is a thought maybe for you as well, what if gravity also exerts a field? Maybe it does. Who knows? It is handled as such in modern astronomy and modern physics now, as if it was a field. And we just call this field space-time, if you want. It is a field. It has field equations, Einstein's field equations, and this field is being manipulated by mass and acts with the speed of light on another mass. So, yeah, I don't know what else to say here, really. This is a very silly argument, and it would disagree with electromagnetism. I'm sure you don't have a problem with electromagnetism. Oh, sorry. No, go away. You go away.
Okay. If in any case A and B approach, it is not because A moves B towards itself or B moves A towards itself,
I'll disagree.
but owing to some causes which affect the space in which A and B are situated, and which causes act on A at A.
Well, you read that briefly. I like the part about the space is manipulated. That was great.
A moves B and B moves A is ignorance.
How?
And is what is meant by attraction. It is also worse than ignorance to justify idleness by asserting that the true cause is indifferent, or to justify ignorance by asserting that it is unknowable.
Why?
This reasoning applies to every species of attraction.
It is a little bit. And I hope you don't find mine boring. But yeah.
Whatever may be the pomposity of equivocal terms in which it is described, universally, bodies cannot push other bodies towards themselves. This is a fact.
How? This was just semantics. There was nothing there, nothing of substance. There was no arguments there. There was no calculations. And you just say, well, if that's not over here, how can it affect that? Well, how can I, from my moderately comfy office chair here in Austria, affect you when you're not here? How can I do that? Well, maybe because I can do something that affects you. I can manipulate something that connects us. I can shine a light at you, for example. If you're like 100 meters away, I can shine a light at you. You would see the light, even though I'm not there.
Let's take a look at another experimental example, this time with the addition of D, as you can see on
he criticizes science for not doing experiments, but then goes off to only cite examples from a book that have no practical relevance.
Right-hand side. If A and B are said to repel one another, and that B makes A move to C, and A makes B move to D, we have to bear in mind that while A is moving to C, it is in force only in that direction, and cannot, therefore, be moving B towards D.
Of course it can.
Likewise,
Why
while
can it not?
B is moving to D, it is
It can only do one thing at a time, and that's a rule now. Now, of course it can. Why should it not? It's the exact same explanation. The electric field, in this case, it could be the same sides of two magnets, so the two positive sides of a magnet. It could be electric charges that repel each other, minus and minus, or plus and plus. Of course, they can manipulate each other. Why not? Hello, Igor. How nice of you to be here. Yes, it's cool that you're late. And feel free to rewatch later. Thank you very much, as a matter of fact. I'm a little bit of a goose because, I started streaming in Firefox, and I remember that I need to stream on Chrome. But yeah, feel free to have any interaction as you see the chat is rather dead.
enforced only in that direction and cannot therefore be enforced in the contrary direction so as to move A to C. Every species or example and variety of attraction and repulsion are therefore absurd.
What? How? Because, oh my God, this is very silly. So he says, because this mug is not this mug. I have two mugs. This one is for water, and this one is for coffee and tea. Because these two mugs here are here, and this one is here, and that one moves over there, and this one moves over there. They couldn't influence each other. How? Why? This is not an argument. Why? How would you say it? And he's criticizing us for not doing experiments and for saying hypothetical stuff. I let you draw the conclusions.
The truth and reality is this: matter is in all cases the conductor of motion. If a body moves, it is because it is the patient of some sufficient momentum.
Matter can certainly conduct motion. No one's disagreeing, but it's not the only conductor of motion. And motion isn't a single thing. It is a force can exceed motion, even though the force itself is not motion itself. I don't know. This is very semantical and very philosophical, if I dare call it philosophical.
Of body or matter acting on the side from
and Igor, thank you for leaving a like. Highly appreciated.
Which the body moves, and only in force in that direction. Some adopters of attraction talk by false analogy of drawing, others of pulling, lifting, etc. Laplace invents gravitating atoms and gives them a philosophy.
Interesting how they write Laplace. I assume they are talking about the physicist.
Of 6,000 times that of light, which in some way, known only to himself, performs the work of bringing the body in. Others imagine little hooks as to drawing, pulling, etc.
How is this relevant?
It behoves them to show the tackle.
We know about
the
electric
levers,
fields.
the
The
ropes,
Maxwell equations describe the force of electromagnetism perfectly, bearing quantum effects, of course. Why? I don't know. This is so confusing. He's advocating against forces in general now. This has turned south quickly.
Etc. How about this? Why don't you, after watching this video, go outside and try to experiment with these absurdities and assumptions?
Yes,
why
please
don't you try to
hold two magnets across my shot. I don't have any magnets here, I'm afraid. Hold two magnets across from each other and wonder how they can attract or repel each other, even though they're not at the same place as the other.
One object to gravitationally attract another object nearby. Go for it. It won't work. The only way it will work is that if you yourself push something towards something else.
No, you can use a magnet.
Hence, creationist universal intelligent design. The fundamental truth, and most of us know this deep down, is that when you push aside all the assumptions, inventions, optic illusion, fabrications such as gravitation, is that the realms and sky above us is created and is controlled by the creator and his divine agency.
The issue is, if you go in with that assumption in the first place, why talk about science at all? If you go in and you say, no, it's created by God, which I suppose you're entitled in saying, I just don't see how this would bring us forward as a species, but sure. If you say, no, it was God, and that's it, well, why talk about science in the first place? Makes no sense to me.
And that the sun and the moon have been set into motion and operation in order to serve human beings down below on Earth. Let us be objective, though.
How does the moon serve us? Kind of not at all, or does it?
acknowledging
I mean,
that
it does in real life because of tides, because of this and that, but that's neither here nor there.
every single human being, whether a cosmologist or otherwise, they wish to understand as much as they can, and of course, sometimes in different ways, what on earth is going on upstairs, who or what is up there. For example, many people, they want to know if there are aliens. Are there other places and locations up there or out there?
Sure. That'll be
Is there a
interesting.
life after
I'll
death?
take the knowledge.
Where do
Gather.
people go to when they die?
I
Will
don't
I ever
think they
see
go anywhere.
and reunite with my
I think when I die, I'm dead. That's it. I see conscience as a side effect of sufficiently complex system of delegating tasks. That's a nervous syndrome, if you want. But that's just me. I may be wrong.
my loved ones again? What is the
I
purpose
would
of
love
life
to,
on
but
earth,
I don't think I will.
etc., etc.? Many human beings say that the answers to those questions and inquiries is most likely upstairs.
I'm skipping the
Our
religious
exploration,
part, okay?
concrete idea of what gravity really is.
Rest of the video. I don't know. Wait, he's talking about
Continuous camera footage, not a single video. You see, you can go and check this out for yourself. System, there was not
Sorry.
one single video where the entire Earth has been filmed at 360 degrees from space with one continuous.
I mean, first of all, how would you want to film 360 degrees of the Earth? I'm not sure if he's aware, but you can only at most see 50% of a ball. And if he means 360 degree, if he means that you would like to film a full rotation, I think there was that was geostationary. That there was some TV station that had their own satellite that would stream Earth from space continuously, but this was geostationary, so it could only ever see one part of Earth because as Earth was rotating, the satellite was moving around it only seeing the same spot, if you will. I should probably do it like that. So it's rotating it like that, right? But why would we need to? We understand how Earth rotates either way, and if we provided such a thing, and I'm sure someone would say now, oh, I know what this is, and I can bring it up. I don't by heart, okay? So even if we did provide such a thing, you wouldn't care. You would say it's fake or it's CGI. You see the problem. You go in with your conclusion that Earth is flat, and you say either it's not there, so that's a problem, or you say, well, it's fake. You see how this is unfalsifiable for you, and that's a problem.
Camera footage, not a single video. You see, you can go and check this out for yourself.
I don't
now,
know.
You have
that.
to ask yourself a question. Is that really by coincidence? Or is it because nobody has really been to space? You probably still think this.
You know how it takes 24 hours? Who would watch a 24-hour video? Just because it rotates extremely slowly. If you want to understand just how slowly it rotates, take a watch, an analog watch, put it in front of you on your desk, and look at the hour hand. And the hour hand moves twice as fast in angular speed as Earth rotates.
This is some kind of a joke, don't you? Don't you? Put it this way.
How?
Gravity is none other than a magical, fictitious, dubious, and imaginary force that has been created and reinforced by and for modern cosmology. It is very similar to the Coriolis effect.
Gain?
You see,
how is it similar to the Coriolis effect? Whoa, where did that one come from? That's interesting.
Cosmology. It is very similar to the Coriolis effect.
How?
You see, in order to conceal or deny the real force and divine agency that is behind the sun, the moon, the stars.
What's Coriolis? I should elaborate how that's wrong. What's Coriolis? Or Coriolis? Coriolis. What is it? Why is it? So imagine you have. I like to do it with a merry-go-round, right? Because that's the first time I truly experienced that. Let's say here's the center of rotation, and it rotates that way, right? So this whole thing turns around, right? Like a plate or something. And you have person A standing here and person B. So that's Bob and Alice. Bob, or as Ron Atkinson says it, I'm doing the best impression here. Bob. That was poor. I am usually doing a better job. I apologize. And here's Alice, and Alice and Bob are playing ball, right? So Alice now has the ball, and she throws it in this direction. Now, if the rotation was 0, it would just go straight ahead as we used it. But because, okay, so she throws it, right? That's a, wait, I need a different color probably. That's a ball. And she throws it. Okay, cool. She throws the ball, but because this is turning, and the ball, of course, doesn't know anything of this turn, it just keeps on going because it has left the reference frame here. It will go continuously. The outside, the ball will fly exactly how we are used to, but by the time it reaches Bob's former position, Bob will be here. And Alice will be over here. So from the reference frame of them two, so that's the outside. Oh, sorry, outside frame. Right, this is what happens on the outside. And now I will copy it because I brought my own drawing pad and it can copy stuff. Oh, sorry, I should also copy it maybe if I actually intend to copy it. There we go. All right, just going down here. But for the inertial reference frame, oh, come on, let me draw, please. Okay. Hello, can I draw? It doesn't let me draw anymore. Hello, would you consider letting me draw? Actually, okay, you don't. Well, I'm going to have to take things into my own hands then. What do you want from me? What? That's weird. That hasn't happened before. Hello. Can I? If I just move that, is it happy? It's not. It's still very much not happy. No, I can't. I can erase, and I can move, but I can't write anymore. Well, that's interesting. Hang on one second, please. I'm so sorry. We are having technical difficulties on the drawing side here. Very random technical difficulties as well. Dear God. I'm saving that as gravity video. Now I'm saving it, and I'm closing it, and now I'm opening it back up again. There we are. And I'm opening the Gravity Arnold thing, and now I'm restreaming it. There we go. Can I write something now? I still can't. Wow, that's weird. That hasn't happened before. It's broken. I just restarted it. Why is it so broken now? That's so weird. Why would you do that, you silly program? Oh. Whatever that is doing. Would you mind, actually? Would you mind? How bizarre is that? I'm sorry. Something's going on here. Huh. Very strange. Now it has started working again. Very strange. Okay. Regardless, I'm sorry for the break. From the inertial. Now maybe the rotating frame, I should say. Rotating frame. So from the rotating frame, Bob and Alice are stationary. And the ball is moving weirdly. Alice throws the ball, and suddenly there's a deviation to the left, and it's quite strong. So this is what Alice would see from her reference frame. So there's the difference. Here's the outside frame. On the outside frame, the ball travels straight, but Bob moves. But of course, from their frames, where they're stationary, the ball in between drifts off to the side. And it's very alienating and irritating. If you're ever on a merry-go-round that's tall, that's big enough, I cannot encourage you enough to do that. It's so fun, so much fun to play just a game of catch with a ball like that. It is mind-numbingly difficult. Okay, so and now, why did I explain that? Because he said gravity is similar to Coriolis. In which way? How is it similar? It's not. Very, very strange thing to.
And the rest of the celestial system upstairs. The forgery
Very strange,
and
very
teaching
strange.
of gravity in modern cosmography, whether by accident or intentional, is one of the crimes of the utmost gravity.
Oh, come
one of the
on.
ways that
Oh, it says it down here, so it's. God.
this is achieved is by using
can't.
optic
I
illusion
can't.
and CGI in order to create the illusion of great distant suns,
How? Why?
moons, stars, planets,
You
and other
you
objects,
just say no.
as well as
That's it.
their massive sizes in contrast to this
As a
tiny.
matter of fact, I have you. Not to mention that you can somewhat take pictures of it. I had I was visiting my parents over the weekend, and my flatmate here was coming with me to see the countryside because she lives in the city, of course, as do I. But I get to visit my parents every now and then, and she was asking to come with, so I did that, of course. And I'd like to show you this picture without showing you my Google Drive. Can I do that? Yes, I can. Hang on. I'm downloading these 3 pictures here. Yeah, those are all of them. I'm downloading them. Oh, sorry. I'm downloading these 3 pictures here from my Google Drive, and I will be sharing you the window here. Because he says optical illusions. This is what bothers me. Because certainly some of them are artist renditions or are actually CGI and things like that. That happens. That's normal. Every visualization can carry a certain amount of error, and I think a point can, but not should, be made for saying that. Well, we should stop with every kind of visualization. I don't think that would be helpful, but it would be an argument of sorts. So I'm sharing this window now here. Yes, exactly. You can see it when I can change it a little bit position. That's nice. Okay, so as you can see here, something is there. Something's also here, if you look at it close enough, and then there's something here, here, and here. What are these things? What am I looking at? That's Jupiter and the 4 Galilean moons. That's Jupiter right here. Those are the 4 moons. Nicely in line. So nice. Unfortunately, I did not see the moon pass in front of Jupiter. That would have been extremely cool to see that. But yeah, so this is one of them. I took this one with that phone right here. My phone has eyes. I took it with this phone right here with a cheap adapter that you fix to a telescope, which hurts me as an astronomer. Just the principle that exists hurts me, but I'm using it. As well as a 20 or 30 or something like that Euro telescope I got from our equivalent of eBay listings or Craigslist or something like that, because we have a specific place for that. This is how I took this image, right? Does it look like Jupiter? No, not on its own, but I have a remedy. This one looks like Jupiter. I also took this one with my phone, and I'm very proud of it. I was extremely lucky to see this picture. So you can see the Jupiter here. It's so cool. Oh my god, is it cool? So when you look at Jupiter, the two maybe can I to be fair, nowadays almost everything you see are AI manufactured images, and I'm very sad about that, frankly. But what can you do about it? Hang on a second. So Jupiter photo. Hello, everyone in the chat, by the way. Feel free to chat with me at any time you'd like. Yeah, there is a nice close one. So when you look at Jupiter, when you look at Jupiter. Oh, there we are. When you look at Jupiter here using NASA just to annoy the flat earthers, when you look at Jupiter, the two stripes you see are these two usually, right? These two are the darkest. And when you look again at the one I took, you can see that. Oh my God, how cool is that? Look at it. I mean, it has bad chromatic aberration. Chromatic aberration in astronomy means that here you can see blue, a blue shade, and here you can see a red shade, right? But you can see 3 of the moons because it's a little zoomed in, right, in comparison to the other one. This is the other one, and this is the one I took with less. Oh, what's it called in English? Oh, I don't know. When you pick the time of how long it's supposed to collect the light, I can't think of the word right now. I'm sorry. Exposure. With a shorter exposure time, you can see the stripes on Jupiter. And again, I took that with equipment that cost me less than 100 euros. And I'm sure you could do even cheaper. I didn't even try to do it cheaper. And you can do the same with Saturn. This is a picture I took essentially with hold to the ocular of my telescope. Just with a plastic grip that holds both of these things so they don't move all that much. This is how I took this picture. Now tell me that doesn't look like Saturn. How is this CGI? I took this image, and I can see I can see bad compression artifacts here, because at the time I took this picture, I was not smart enough to take the raw picture. I had it set to JPEG, unfortunately. Silly me. Either way, let's continue. So when he says everything's CGI, well, no, it's not. It's CGI because it looks awesome.
Globe Earth that is supposedly spinning in the middle of nowhere. This is all CGI, make-believe, and pure science fiction. The truth is more terrifying than fiction. Indeed, indeed. We can assure you 100% that the sun is a local light exclusively
you kind of
operating above
can't,
the Earth.
can you?
That the sun has absolutely no gravitational pull on the Earth whatsoever.
I disagree.
And that the sun is much, 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 much smaller than the Earth, for sure, over 1,000 times, indeed. Yes, this sounds ludicrous and outlandish,
It
even
does.
if you are watching it for the first time. Nevertheless, this is
sound outlandish, it sounds
effectively as you
totally
can.
I also like how he peddles this model,
First and foremost, in relation to the 3 basic factors.
which is so interesting because this video was released 2 weeks ago, so well past the final experiment that showed even for flat earthers that there is a 21st hour sun in the south at a time where they predict that it shouldn't be.
We mentioned earlier.
Naturally, of course. Okay, so I think I will at some point stop with this video now, because now they're going to density and buoyancy, essentially. Which even small insects freely dash around. Where is gravity? Well, it's still there. They have wings to generate lift. It's not that hard. If they didn't have the wings, they'd fall down. It's as easy as that. I don't know what else to explain it. So, and because the stream is rather poorly watched so far, I think actually I'll call it quits here. There is nothing I can extract from this video other than that. There is, in case you're wondering, there is a video incoming for you that is an expansion on my quarrels with kryptonite physics, and in his regards to what we can see and what we can't see, and I will show him thoroughly wrong, of course, as is my doing, kind of. I feel almost responsible for kryptonite physics and for showing him wrong now. So yeah, but I think I'll leave it here. Mostly, to be quite frank with you, because no one's watching it because I'm tired. Okay, so people, thank you. Thank you also for, if you're rewatching, thank you very much. Maybe consider leaving a like, and maybe considering subscribing. And I will hopefully and gladly welcome you to the next stream that I do. Hopefully this time on Chrome as well. So with that, thank you again, and I will see you in the next video. Or well, you will see me in the next video, but I will see you in the next stream. So until then, have a good day. Goodbye.